Hi there, everybody. Today we're going to be talking about anti-differentiation, or what we call the indefinite integral. We always start with what we already know. So we already know differentiation means the process of finding the derivative. If you were given f of x equals x squared plus 2, then f prime of x would equal 2x. If we were given f of x equals x squared plus 4, then f prime of x would also equal 2x. Okay, we're going to talk about that in a minute. If we had to explain to someone how to find the derivative of a polynomial type function, what do you think you would say? Probably something like, bring your power down, and we're going to multiply by a coefficient if there's one there. There was none in the example we did. Right, so that takes care of bring the 2 down in front. And then the next thing we usually do is subtract 1 from our power, and that gives us our new power. So 2x, subtract 1 from the power, that gives us our x to the first power. All right, so now that we probably have extinguished everything I can introduce to you in this course involving derivatives, now we're going to start to talk about something called the antiderivative. So to find the antiderivative, you would do the opposite of each one of the operations and in the reverse order. Therefore, to find the antiderivative of a polynomial type function, well, if we go in reverse order, if we subtract 1, we're going to add 1 to each power. And since we multiply, we want to divide. So we're just doing the opposite. Now, let's look at our example from above. So if this is our antiderivative and we work backwards, what problem do you see? Okay. What problems do we see? Well, we can't tell if there's a constant. In the original function. So basically what we're going to do to help us deal with this problem is, after we're done doing the antiderivative, we're just going to add a c to the end. We're going to add something there to sort of account for the fact that there could be a constant. Okay. So our new word for the day is anti-differentiation, and this is the process of finding an antiderivative. Okay. And basically all we're doing is going in reverse order and undoing the derivative. Another word for this process is called integration. So I know this sounds silly, but we're going to do the reverse order of the first example we did. So if f prime of x equals 2x, what is f of x? So this is a derivative. We want to go backwards to the original function. Using our rule, we're going to add 1. So if the power was 1 to begin with, it's going to be x squared. And if we divide by 2, we just wind up with x squared. So our original function is x squared, but we have to remember to account for there possibly being a constant in the original function. Okay, so what does this mean to us? It means an antiderivative is really a family of functions. Okay. We're going to talk about this more next year and how to find C in greater depth in AP Calculus. But for right now, you can think of it like this. Okay. That's a terrible parabola, but we really, C could be anything. So we're really coming up with a family of functions that are all parabolas. Okay. And, once again, we will work on finding C next year. But for the time being, we just want to introduce you to the notation we use for an antiderivative and some of the basic rules on how to use them. So First and foremost in math, every time we learn something new, we have to talk about the notation we're going to use. Okay, so now I'm sure you guys have seen that sign before. Okay, this sign is an integral sign, and basically when we're dealing with types of problems, we're going to be seeing something like that, where we'll have an integral sign, then some sort of function, and then dx. Okay, so this guy here is called an integral sign. And when you see that sign, it means find the antiderivative. We'll have different meanings in different applications, but right now we're working on finding the antiderivative. This piece here is called the integrand. And then we have what's called a variable of integration. I know you're probably really mad that I'm making you write all this stuff down, but it really is important. You know how I stress understanding what things mean. So if we take the antiderivative like we did on the other page and we go in the backwards direction and we undo, then we get this guy here, which is our antiderivative. And most textbooks will use f of x lowercase to an uppercase. And we're going to stick that way with the very beginning, and you will see things will get more complicated as we progress through the course next year. Okay, but for now, all you need to know is whenever you see something with an integral sign, this is really the derivative of some function, and to undo it, we're going to use our rules. Okay. So some basic integration rules we start with, well, this is the one we talked about on the previous page. Add, 1, divide. Okay. These other 3 rules are just like sort of variations, like whenever I gave you limit properties or derivative properties, it's things we can do. For instance, this one here just means if it's just a number, we're just going to attach an x to it. Here, if we have some multiplier, we can always bring it outside if we need to. And this rule just means we can take the antiderivative one term at a time. Okay, again, this is the big one for the day, and these we just sort of are going to apply without even realizing it sometimes. So moving through some real basic examples. Find each of the following antiderivatives. So the antiderivative of a plain old number, we're just going to put an x on it and plus c. Okay, so if you wanted to use this notation, you could, but I know it seems weird, but we really usually just write our answers like that. Okay. So my antiderivative of 3x plus 2. So now I have an x there, so I assume that that power is 1. Add 1 to the power and divide by that number. Now I move on to the next term, plus 2x. And then I always have to account for some random c in my equation. The antiderivative of 3x squared plus 2x plus 3. So I'm going to go term by term, add 1 to the power, divide by that number. Add 1 to the power, divide by that number. If it's just a number, I'm just going to tack on an x and account for the plus c. And now you guys may start to do your simplifying in your head, and that's quite all right. But I just want to show you the steps. Moving on, the antiderivative. So now I have some negative numbers. Still, I'm just going to add and divide. So I have negative 2x. If I add 1, I get negative 2. Divide by negative 2. Plus 20x. Add 1 to the power. Divide by that number. Plus c. This is going to cancel. You're going to be left with x to the negative 2 minus 5x to the negative 4 plus c. And to save time, we're not going to rewrite that with positive exponents. I'm just going to leave it alone. Okay. Just like when we were doing the derivative, sometimes you're going to have to rewrite before integrating. Okay, our antiderivative rules, nothing accounts for the variable being in the denominator. Okay, so we have to rewrite before we can integrate or take the antiderivative. So I have x to the negative third dx. Now I can apply my rule. So it's just a simple matter of rewriting things to help you. So I take the antiderivative, that's going to be x to the negative 2 over negative 2 plus c. Some of you may prefer to write it like this. Some of you may prefer to write it like this. All of those are things that you're just going to do naturally when you're taking your calculus course next year. But right now, just getting to that step is really what I expect you to be able to do by the end of this lesson. Antiderivative of radical x. Now, if I look up here, I've got no rules, nothing that helps me with the radical sign. So just like we did when we were taking the derivative, we've got to rewrite any radical signs with powers. So I need to figure out what function this came from. So in order to do that, now I'm going to add 1 to the power. 1/2 plus 1 is 3/2. And I would divide by that number. Now this usually becomes a huge old mess. So basically what I want to remind you guys of is when we divide by a number, it's the same as multiplying by the reciprocal. So whenever you're dividing by a fraction, I would kind of stay away from that. And I would say, okay, x to the 3/2 multiply by the reciprocal plus c, and your life will be a lot easier in the future. A couple more to go, and then we will be done. Okay. So we're going to rewrite this guy before we begin. So I have the antiderivative of 5x power over root over 3. Now this 5/3 is really messing me up. Okay, so what I could do is one of those rules on the other page, we can move any multipliers. That's kind of given us a little confusion, and move it out to the front if we don't want to deal with it. Okay, let's take one moment here. That would be an example of this rule right here. Okay, I can move any multiplier out. So now this is going to be 5/3 x, I'm going to add 1, 2/3 plus 3/3 is 5/3. And I'm going to divide by 5/3 or multiply by 3/5 plus c. And then you see here, this is going to cancel each other out, and your answer is just going to be x to the 5/3 plus c. Oh, I didn't give myself a lot of room there. Let's look at the next guy. Oh, this is a simple one. Okay, I don't have a backwards product rule, but I could just distribute this out. 2x squared. What do I get next? Minus 3x plus 4x plus x minus 6 dx. Okay. And you would wind up getting, so I have 2x cubed over 3 plus x squared over 2 minus 6x plus c. And just remember, when these two things go away when you take the antiderivative, and you're just left with the plus c at the end. The antiderivative of 2 over radical x. So now we have to remember, same thing, similar situation. We need to rewrite this. So I'm going to take it out of the radical sign and move it to the numerator so I can apply my rule. If you want, you can bring your multiplier out front. This one's not that bad though, so it doesn't really matter. So now you have 2 times negative 1/2 plus 1 is x to the 1/2. Divide by 1/2 means you're multiplying by 2. And if you do a little simplifying here, you get 4x to the 1/2 plus c. And if you're unsure of yourself in any situation, all you have to do is take the derivative and you should get what's after the integral sign. A couple more to go and we will be on our way. I don't have a quotient rule. I've got nothing that gives me a way to work backwards, but I can simplify. Okay, so these are all examples of where you're going to have to clean things up before you begin. X cubed divided by x, x squared. 2x squared divided by x, 2x. Negative 4x divided by x is minus 4. So now I'm just taking the antiderivative of this function. X cubed over 3. 2x squared over 2 just gives me x squared minus 4x plus c. So now that we practiced some relatively easy rewriting, let's talk about situations where our rewriting may be a little bit more difficult. So now I have x plus 1 over radical x. Well, don't get scared, just rewrite. Now we know with our exponent laws, whenever we're dividing by like terms, we subtract. So I have x divided by x to the 1/2. 1 minus 1/2 is just the 1/2 power. Plus 1 over x to the 1/2, well, we're going to bring this guy up as a negative power. And now go term by term. Add 1. 1/2 plus 1 is 3/2. Divide by 3/2 is really multiply by 2/3. Negative 1/2 plus 1 is 1/2. Divide by 1/2 is multiply by 2. Tack on your plus c, and you have the antiderivative. Last example. Rewrite x to the 1/3 times x minus 4. Hopefully by now you see you're just going to distribute. 1/3 plus 1, x to the 4/3, minus 4x to the 1/3 dx. So I have x to the 4/3 plus 1 is x to the 7/3. Divide by 7/3 means multiply by 3/7. 4x 1/3 plus 1, 4/3. Divide by 4/3 means multiply by 3/4. Simplify what you can. Our 4's are going to cancel. And I think at this point, we can call it a day. Okay? I hope you got a little bit out of this, just understanding how to go backwards and get the original function, and that would be the derivative. Okay, so this is going back and forth between a derivative and the original function. Okay, thank you. So long.